Hello, good evening, good morning, wherever you are. So welcome to my YouTube video channel. So I want to explain a little bit about empirical formula and molecular formula. First of all, what is an empirical formula? An empirical formula refers to the simplest whole number ratio of various atoms present in a compound, whereas the molecular formula shows the exact number of different types of atoms present in a molecule of a compound. Here we have the formula, which means that says that molecular formula equal to empirical formula times the number of atoms that present in that compound. So n ranges from 1 to infinity. So when you want to calculate n, number of atoms, is equal to molecular formula divided by empirical formula. So here, guys, I have an example that I want to explain using two different types of formulas, and you are welcome to choose any formula that you are familiar with or the one that you find to be quite simple and straightforward. So here I have an example. What is the simplest formula of the compound which has the following percentage composition? Here I have carbon, which is equal to 80%, hydrogen, which is equal to 20%. And if you combine 80% plus 20%, you are going to get 100%. If the molecular mass of the compound is equal to 30, calculate its molecular formula. The relative atomic mass of carbon is equal to 12. The relative atomic mass of hydrogen is equal to 1. So the solution is, here we need to write the element, its percentage, its atomic mass, its relative number of moles, the simple ratio, and the simplest whole number ratio. So here we have carbon, which has 80%, and we have hydrogen, which has 20%, and the atomic mass of carbon must be equal to 12, like this. You are given those relative atomic mass when you are in an exam, when you are in a test. So don't worry about the atomic mass, because you are going to be given with these relative atomic mass. The atomic mass of hydrogen must be equal to 1, and this is the one. So when you want to calculate the relative number of moles, you are likely to take 80% divided by the atomic mass. Here, when we take 80%, 80 divided by 12, we are likely to get 6.66 number of moles. And when we take 20 divided by 1, we are likely to get 20 moles, number of moles. So what is about the simple ratio? Here, for carbon, we take this number and we have to divide the smaller number of moles between this and this. And when we compare this number of moles and this, we can find that 6.66, it is the smaller number compared to 20. This is the reason why we are going just to divide by 6.66, and we are likely to get 1. So here also we are just going to get 20 divided by 6.66. 20 divided by 6.66, we are likely to get the 3. So the simplest whole number of ratio is equal to, for carbon we have 1, for hydrogen we have 3. So the empirical formula is written as carbon you have 1 atom, and hydrogen we have 3. So this is the empirical formula. What about the molecular formula? Molecular formula, as we have seen previously, is equal to the empirical formula times N. So here we have empirical formula, which is equal to carbon 1, hydrogen 3 times number of atoms, which must be equal to the relative molecular mass, which is equal to certain relative molecular mass. So what is the atomic mass of carbon? The atomic mass of carbon is equal to 12 times 1. When you multiply 12 times 1, you are likely to get also 12. Plus, hydrogen has the atomic mass of 1 times 3 times this N, which must be equal to certain. So 12 times 1, you are going to get 12, plus 1 times 3 is equal to 3 times N, which is equal to certain. 12 plus 3, you are going to get 15 times N, which is equal to certain. So N must be equal to certain divided by 15, which is equal to 2. So when we want to calculate the molecular formula, we need to take the empirical formula, which was 1H3 times 2. So 2 times 1, we are going to get 2 carbon atoms, and 2 times 3, we are going to get 6 hydrogen atoms. This is the molecular formula of the compound. The second alternative method that you might use, the second method, which is quite straightforward and easy for anyone. Second method is, we are going to calculate the molecular formula first, and we are going to calculate the empirical formula after. So it is done in this way. We have to take carbon atoms, which has 80%. You have to take the percentage of the atom, which was 80 divided by 100, which means percent, times the relative molecular mass, which was 30, divided by the atomic mass of the carbon, which is 12. So here, if you calculate this number, you are going to get 2400 divided by 120000. Here you are going to get 2, which is the same as here. And when you want to calculate hydrogen, you are going to get 20 divided by 100. 100, it is the percentage. So hydrogen here has 20%. Times also the relative molecular mass of the compound, which is equal to 30 divided by 1. 2 times 3 is equal to 6, and those 2 zeros divided by 100. Simplify. Here you are going to get 6, like this one. So the molecular formula is going to be carbon 2, hydrogen 6. So if you want to calculate the empirical formula, the empirical formula must be equal to, here we need to take the simplest number here. The raw number is equal to 2. So we need to divide each atom by 2. When you take carbon 2 divided by 2 and hydrogen 6 divided by 2, you are going to get carbon 1 and hydrogen 3. This is the empirical formula of the compound. Yes guys, thank you very much. I think this is the second method is quite easy and straightforward. I wish each and everyone might adapt to this formula, as it is faster, and it cannot consume a lot of time, so that you can do it very easily. So thank you guys. Please subscribe and hit like button to my YouTube channel. Share it to your friends and colleagues, so that this is the one that will motivate me. Thank you very much guys. Blessings over blessings.